Hello students, in today's video you will find space lattice or crystal lattice and type of unit cell. First I am going to tell you space lattice or crystal lattice. Space lattice or crystal lattice. The regular arrangement of constituent particles, that is atoms, molecules or ions of crystal in three-dimensional space is called space lattice or crystal lattice. The points used for representing the position of constituent particles in the lattice are called lattice point or lattice sites. Then we can also define an array of points that shows how the structural or constituent particles, atoms, ions or molecules of crystal are arranged in three-dimensional space at different lattice site is called space lattice or crystal lattice. Once again, an array of points that shows how the constituent particles are arranged in three-dimensional space at different lattice site is called space lattice or crystal lattice. Next point is now characteristic of space lattice or crystal lattice. Characteristics. Now characteristic of space lattice or crystal lattice. First, each point in a crystal lattice or space lattice has same environment as that of the other points. Second one, each point in the lattice represent the constituent particle, atom, ion or molecule. Third important character is these lattice points are basically joined by a straight line, by straight lines to bring out the geometry of the lattice. Now, next I am going to tell you unit cell. Unit cell the smallest portion or the smallest unit which on repeating its own dimension over and over again in three dimensions or in different directions generate a new lattice or new crystal lattice is called unit cell. Once again, the smallest unit or smallest portion of crystal lattice which can generate a lattice after repeating its own dimension over and over again in various directions or in three dimensions. Now, characteristic of unit cell. First characteristic, unit cell is characterized by first axial distances. And what are these axial distances that I am showing you? edge length A, B, C. Edge length represented by A, B, C. And these edge lengths are along the three axes X, Y, and Z. Like that, three axes. Now, second character, axial angles alpha, beta, and gamma between the edges B and C, C and A and B. Then that way unit cell is characterized. Once again, unit cell is characterized by the relative edge length A, B, C along the three axes X, Y, Z. These are called axial distances A, B, C. Second one, axial angle alpha, beta, gamma between the edge pairs B and C, C and A and B. Now next point is type of unit cell. Third, type of unit cell. Type of unit cell. First, primitive unit cell. Primitive unit cell. And second one, centered unit cell. Centered unit cell. First, primitive unit cell. A unit cell in which the constituent particles, atoms, ions, and molecules are present only at the corner of the cell is called primitive unit cell. Now, I am going to tell you different type of unit cell, primitive unit cell. There are 7 types of primitive unit cells, and it is called 7 crystal systems. Now here, for that 7 crystal system, I am going to tell you first type of primitive unit cell. Primitive or simple unit cell type. First is here cubic unit cell. Cubic unit cell. Now in this unit cell, cubic one, A equal to B equal to C, all the three edges are equal and angles are also equal, alpha equal to beta equal to gamma equal to 90 degree. Equal to 90 degree. Some example of cubic unit cell I am telling, like NaCl, KCl, copper, like that many examples are there. Now second one is rhombohedral or rhombic. Or rhombic or rhombohedral primitive unit cell. In this unit cell is A equal to B equal to C, alpha equal to beta equal to gamma is not equal to 90 degree. And examples in this is rhombic sulfur and other examples there. Number 3, tetragonal. In tetragonal, For example, here in this case A equal to B is not equal to C. Alpha equal to beta equal to gamma equal to 90 degree. Tetragonal, white tin, tin oxide, these are example. Now like white tin, SnO2, TiO2, like that, others are there. Number 4. Now hexagonal. In this A equal to B is not equal to C and alpha equal to beta is not equal to, alpha equal to beta equal to 90 degree and gamma equal to 120 degree, like graphite. Graphite, zinc, like the zinc is also there. Some more example, zinc oxide. Next, here monoclinic. Monoclinic primitive unit cell. Now this is needle shaped one, monoclinic. Here A equal to B is not equal to C and alpha equal to gamma equal to 90 degree and beta is not equal to 90 degree. Then in this case monoclinic sulfur is a most important example is monoclinic sulfur. Monoclinic sulfur is most important and gypsums. Like that, some examples are here. Glober salt, these are some examples. Glober salt, the CaSO4, 0.2S2O, these are some examples. Now triclinic primitive unit cell. In triclinic A is not equal to B is not equal to C and alpha is not equal to beta is not equal to gamma is not equal to 90 degree. Triclinic. Potassium dichromate, most important example, K2Cr2O7 and boric acid are some examples of triclinic primitive unit cell. Now orthorhombic. Orthorhombic unit cell. In orthorhombic, A is not equal to B is not equal to C, but alpha equal to beta equal to gamma equal to 90 degree. And here alpha equal to beta equal to gamma equal to 90 degree for this one. And for orthorhombic example, orthorhombic primitive unit cell, the most important is KNO3, rhombic sulfur, BaSO4, like that. There are some example for this case also. And rhombohedral, most important, NaNO3 is there, CaCO3. There are some example, arsenic, antimony. These are some examples of rhombohedral. Then these are some 7 types of primitive unit cells. And again, next class I will tell you very interesting topic of the same chapter. Thank you.